In this explainer, we're embarking on a journey that borders the very edge of human understanding. We are stepping completely away from traditional philosophy and venturing into a space where the microscopic laws of physics meet the ultimate mystery of human existence. We're going to look at what actually happens to our minds at the exact microscopic boundary of death. Neuroscience can tell you exactly which neurons fire when you feel love, fear, or joy. What it cannot tell you, and has never been able to explain, is why it feels like anything at all. That gap is called the hard problem of consciousness, and a Nobel Prize-winning physicist thinks the answer changes everything we believe about death. Chapter 1. The Hard Problem. So, the hard problem is a term coined by philosopher David Chalmers back in 1995. Now, science is incredibly good at what we call the easy problems, mapping the brain's functional and structural properties. We can track exactly which electrical signals tell your arm to move. But even after mapping every single biological mechanism in the brain, physicalist science hits a total brick wall. It completely fails to explain our inner qualitative feelings. Why does the physical processing of light wavelengths actually feel like the vivid redness of a rose? Ultimately, why is there something it is like to be you? As Chalmers so perfectly put it, why is the performance of these functions accompanied by experience? Think about it for a second. We can easily imagine a highly advanced biological robot, or a zombie, that acts exactly like a human and processes information exactly like a human, but is completely dark inside. No feelings, no subjective awareness whatsoever. The fact that classical science cannot explain why we aren't just biological zombies reveals this massive, seemingly unbridgeable gap between physical matter and subjective feeling. Chapter 2. The Quantum Paradigm Shift. Traditional neuroscience treats the brain basically like a classic computer. It's a Turing machine, where neurons are just binary switches, on or off, 0 or 1. But Nobel Prize-winning physicist Roger Penrose and anesthesiologist Stuart Hameroff realized this classic model just doesn't account for human insight, free will, or that subjective feeling we were just talking about. So they developed something called the Orch-OR theory, Orchestrated Objective Reduction. This theory completely flips the script. It posits that the brain isn't a digital computer at all. It's actually a quantum orchestra, and consciousness arises from non-computable quantum events. Okay, but where could quantum computations actually happen inside a biological living organism? Well, the secret lies deep inside your neurons, within microscopic cylindrical structures called microtubules. They act as the brain's quantum qubits. Now, for a long time, critics argued that the brain was way too warm, wet, and noisy to sustain delicate quantum states. They thought the states would instantly collapse in a process called decoherence. But Orch-OR suggests that these microtubules, because they're surrounded by ordered water and actin gel, biologically shield these fragile quantum superpositions. They protect them, allowing them to process information before they eventually collapse. Let's break down this incredibly complex mechanism into a clear sequence of microscopic events. Step 1. The tubulin proteins inside the microtubules enter a state of quantum superposition, meaning they exist in multiple states all at once. Step 2, according to Penrose, this superposition actually creates a tiny separation, almost like a blister, in the fundamental geometry of spacetime itself. But spacetime really doesn't like this instability. So, step 3, when that instability reaches a critical threshold, it spontaneously collapses. This gravity-induced collapse is called objective reduction, and it is this exact physical snap that triggers a discrete, single moment of conscious experience. And here's the wild part. These collapses aren't just happening randomly. They are highly orchestrated by the biological systems of the brain, happening roughly 40 times every single second. This 40 hertz frequency brilliantly aligns with our brain's gamma waves. So what feels to us like a smooth, continuous stream of human awareness is actually a rapid-fire sequence of discrete quantum flashes, conscious moments just firing off continuously in our microtubule networks. Chapter 3. The Empirical Anomaly. To really test the boundaries of the mind at death, Dr. Sam Parnia launched the groundbreaking AWARE studies back in 2008. Spanning 15 hospitals across Europe and North America, this was a massive undertaking to objectively measure what happens when the human brain completely shuts down. They studied patients who suffered cardiac arrest, which, medically speaking, is synonymous with death. And crucially, they used objective markers like hidden visual targets and timed audio cues to verify if these patients' claims of awareness were actually real or just hallucinations. The findings were absolutely astounding.
40% of cardiac arrest survivors who were able to be interviewed experienced a distinct sense of conscious awareness during the period when they were clinically dead. Just to put that in perspective, that is a massive proportion of patients reporting very real mental activity when their brains should have been completely 100% offline. But there is one specific finding that kind of changes everything. It's called the 3-minute paradox. In a standard cardiac arrest, the brain's electrical activity completely flatlines within 20 to 30 seconds, meaning cognitive function becomes biologically impossible. Yet, one patient accurately recalled highly specific, verified events, like floating above the resuscitation area, the exact physical movements of the medical staff, and even the automated verbal commands of the defibrillator machine. His memories were verified by medical records to have occurred up to 3 full minutes into his flatline state. Let that sink in for a second. Highly structured awareness persisted for minutes, while the physical brain was completely dead. These verified events demand a completely new scientific explanation. As Dr. Parnia noted, these aren't just the random, firing hallucinations of a dying brain. What's happening is that as the brain shuts down, its natural braking systems are released, a process called disinhibition. It actually provides access to depths of reality that our traditional classical biology simply cannot account for. Chapter 4, the physics of immortality. So how do we explain this? Well, we have to look at a foundational principle of quantum mechanics known as unitarity. Unitarity dictates that the total physical information of a closed system can never, ever be lost or destroyed. Mathematically, the past can always be reconstructed from the present. If human consciousness is, at its core, quantum information stored within the microtubules, then it is strictly bound by these unyielding laws of thermodynamics. This leads us to the erasure is transfer principle, which was originally established by physicist Rolf Landauer. When biological cellular death occurs, a massive amount of metabolic energy is released. This terminal surge creates a temporary window of maximum quantum coherence within the brain. During this brief window, the quantum information that literally defines your mind does not vanish. Because of unitarity, it can't be destroyed. Instead, it uploads or transfers to the fundamental geometry of spacetime itself. Now, this theoretical framework perfectly accounts for 2 very distinct paths when a patient enters clinical death. In the case of resuscitation, the heart is restarted, blood flows back into the brain, and that non-local quantum information channels right back into those reperfused microtubules, sparking a highly lucid near-death experience. But in the case of permanent death, the biological scaffolding of the brain dissolves for good. The quantum information simply dissipates and distributes into the broader cosmic geometry. It departs, but it is not annihilated. Chapter 5, the cosmic return. If the Orch-OR theory and the principles of quantum thermodynamics actually hold true, we are forced to embrace a quietly earth-shattering idea. Consciousness is not just some temporary, localized byproduct of biological wiring. It is a fundamental feature of the physical universe. We are simply temporary biological vessels for an intrinsic property of the cosmos. And when the vessel breaks, the essence of what it is to be you remains woven into the indestructible fabric of reality. So I'll leave you with this. If consciousness is quantum information, and information cannot be destroyed, where does it go?